Hello, my peeps. Today's Algebra Nation video is going to cover the left side of page 48, but more specifically, we are going to do problem number 1, part A, and part B.
Hey Algebra Nation, it's Ashley again. Let's get right into it and solve some literal equations. So in this first problem, problem number 1, we're given two different literal equations and we're asked to solve for a variable. Now, literal equations, all that means is that when you solve for a variable, there are going to be other variables in your answer. So you're not just going to get a number for your answer. It's also going to have different variables included. You're just rearranging your equations to isolate one of your variables, to solve for a variable. So in this first problem, we are asked to solve for g. We're asked to solve for g. So what we want to do is get g by itself. Well, let's look at this. All right, we have 3g plus 4h equals 18. What is keeping g from being by itself? Well, there's 3 g's, right? We've got 3 times g. But 4h is being added to that entire quantity 3g. 4h is being added to 3g. We need to get rid of that 4h. You know, in a normal equation, not a literal equation, but an equation with just one variable, say we had 3x plus 4 equals 10. In that case, the first thing we want to do is move away the term that doesn't have an x in it, right? We would subtract by 4 on each side. It's the same idea here. We want to get rid of the terms that don't have x's in them. So how do you get rid of a plus 4h? What is the inverse of addition? Subtraction, so we subtract 4h. And whatever we do on one side of your equal sign, you have to do on the other. So we subtract 4h. All right, let's see what happens. Well, 4h minus 4h, those cancel out, 0. So we're left with 3g on the left side of our equation. Now we have 18 minus 4h. 18 minus 4h. Are those like terms? No. So you can't combine them. Remember, you can only combine like terms. This is like saying I have $18 and I subtract off 4 horses. They're not like terms, right? We're not talking about the same thing. Here we just have a number. Here we're saying we have 4. We're subtracting off 4 of our variable h. You can't combine those two. It doesn't make any sense. So we have to keep them separate. We write this as 18 minus 4h. Now I know some of you may have written this as 3g equals negative 4h plus 18, and that's fine. It means the same thing. You can change the order of those terms. 18 minus 4h is the same thing as saying negative 4h plus 18. It means the same thing. Okay, let's look at our next case. We have 3g. Is g by itself? No, that's what we're trying to do. We're trying to get our variable g by itself. So 3 is being multiplied by g, so to get rid of it, to the inverse, we divide. We are going to divide by 3. Now, whatever you do on one side, you have to do on the other. We've got to do on the other, so we've got to divide the other side by 3. What's this really saying? I have 18 minus 4h divided by 3. Break that into two different pieces. That's 18 divided by 3 minus 4h divided by 3. That's saying the same exact thing. Dividing each piece by 3, that's just what we're doing right here. All right, so we get 3g divided by 3. 3's cancel out, and we get g. So we have g equals 18 divided by 3 minus 4h over 3. Well, let's see. We always want to simplify. So let's see. Can we simplify 18 divided by 3? Does 3 go into 18? Yeah, 18 divided by 3 is 6. Can we simplify 4 thirds? No. So we have 4 thirds h. Make it 4h over 3. Well, guess what, guys? We just got our final answer. We just solved for g. G is equal to 6 minus 4h over 3. All right, let's look at our next equation. In this next one, we need...
No, let's take a brain break first. And since the NBA season has kicked off, how about we go with a basketball brain break? Make sure you have some moves like this guy. Check out the dribbling. Nice. On the EOC. That's what you got to do when you come up to that tough problem. Don't give up. Look how tall that guy is, number 11. Birdman. You dribble the ball between his legs. That's what you got to do on the EOC. Take down the big problems. Brain break's over. Get back to work.
to solve for a. So we see a bunch of different variables. We've got g S, we have A. What do we want to do? We just want to get A by itself. We are trying to isolate A. So solve for A, get A by itself. How are we going to do this? Well, let's see. I'm going to rewrite this question. 9G minus S plus 6A is equal to 8G minus 2A plus 3. Okay, well, can I combine like terms? I look at the left side of my equal sign. Are there any terms I can combine? Well, here we have 9 of G's. Here we have a minus 1S. Remember, minus S is really just saying you have 1S plus 6A. You can't combine those. They're different terms. This is like saying here, G, we have grapes. S, we have squash. And A, we have apples. Can you combine those? No, they're not like terms. Over here, we have 8G minus 2A plus 3. Can we combine any of those? No, they're not like terms. All right, so let's think what we want to do. We're trying to solve for A. We want to get A on one side of the equation and everything else on the other side. So if we want to get A, only have terms with A on our left side of the equation, what do we need to do? I'm going to start by getting rid of this 9G and this 1S. I don't want to have G's and S's on the left. I only want to have A. So 9G, is that a positive 9 or a negative 9? It's positive. So 9G is being added to the side of the equation. How do I get rid of something being added? I take the inverse, I subtract. I'm going to take a minus 9G. Whatever I do to one side, I've got to do to the other side of my equation. Let's see what that gives me. 9G minus 9G cancels out. My negative S comes down. And remember, I can put a 1 there if I want to. Plus 6A is equal to 8G minus 9G. 8G minus 9G. Well, if I have 8 and I take away 9, I get a negative number, right? If I have 8 of something, well, I took away 8. I still got to take away 1 more. Now I go into my negative number. So I have negative G. I bring down my negative 2A plus 3. Well, this is starting to look a little bit better, right? We still got to get this term with an A by itself, though. There's still another term on the left side. We need to get rid of this negative S. A negative S. S is being subtracted from the left. What is the inverse of subtraction? What is the opposite? Addition. So since we have a negative S over here, we're going to add S. And whatever we do to one side, we have to do to the other. All right, so my negative S plus S, well, negative 1 plus 1S. This is really just the same thing as saying adding 1S. Those cancel out, and we're left with 6A. What do we have over here? Okay, S. I'm adding an S. Is there anything that I'm adding S to? Are there any terms that are being combined with that positive S, with that plus S? No. We just keep it separate, right? We are adding a squash over here. Well, we just got a squash. You can't combine it with your grapes. You can't combine it with your apples. You can't combine it with your number. No. So we're just going to write this. We have a minus G minus 2A plus 3 plus S. And that's it. It's okay if you can't combine this term with something else. Just write it separate. Add it on. All right, so let's see. Are we done? No. The goal is to solve for A. We want to get A by itself. And A is not yet by itself. So 6A means that we have 6 times A. We have 6 of something. Well, to get rid of that 6, we need to divide. So we divide by 6, and whenever I do to one side, I got to do the other. Well, that 6 divided by 6 is 1, so I'm left with A on the left. Now, each term needs to be divided by 6. So I'm going to have a negative G over 6 minus 2A over 6 plus 3 over 6 plus S over 6. The same way of writing, dividing everything by 6, saying each term is being divided by 6. Well, let's see if we can simplify, because I know we have A by itself now, but we always want our final answer to be as simplified as possible. We have a negative G over 6. Really, that's a negative 1G over 6, right? Can that be simplified? No. So we can just write that, negative G over 6. Okay, minus 2 over 6. Well, minus 2A over 6. Can we simplify this 2 over 6? Is there a number that goes into each of these? 2, right? 2 goes into the top, 2 goes into the bottom. Well, 2 divided by 2, 6 divided by 2, that's what we get. 2 divided by 2, we'd end up with a 1 on the top. Got our A. 6 divided by 2, that gives us a 3 on the bottom. What about over here? 3 divided by 6. Is there a number that goes into 3 that also goes into 6? 3. 3 divided by 3. 6 divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 3 divided by 6 is the same thing as saying 1 divided by 2. It's just a different way of writing it. This is just a simplified form. But both quantities are the same thing as saying I have a half, right? If I have 3/6 of something, I have a half of something. I have 0.5. It's all the same number, just a different way of writing it. Now finally, s over 6, we simplify that. No. So we get our answer of s over 6. And that's it. We took our literal equation, we got the only variable that we're interested in. We got a all by itself by removing our other variables. You're solving a literal equation, all you're doing is getting the variable you're interested in on one side. You're getting in terms of the other variables. It's okay when you have a literal equation and you end up with an answer that doesn't just include numbers. It includes other variables. That's fine, because that's exactly what a literal equation is.
All this talk of apples, grapes, and squash has made me hungry. Bye.